Right.
We may start with the last presentation, but not the least. The presentation under the title of non-destructive test approach for evaluating high-strength concrete incorporating with palm oil food ash. Dr. Muhd, you may start your presentation.
Okay. All right. Okay.
Thank you.
All right. All right. Can you see my slides?
Yes.
All right. Okay. Okay. All right. Okay. Okay. Again, very good evening. I think this will be the wrap for this session, is it? Okay. All right. Thank you for still with me. Just sharing my simple findings that I think that what can I share with other speakers. So basically, these are also one of the another findings that been done back in my lab with my research team. Right. So another view of the potential of POFA wall itself. POFA as seam replacement, only we conducted what we call as NDT testing, right? Non-destructive test, right? So basically, so what pursue me to do the testing on the NDT? Because one of our strongest and our in my institute is NDT summon, okay, non-destructive test. So we have all in fact I'm my institute, which lead by me, we been invited by industry, our local industry, to go for inspection, and from there I think NDT is one of the things that need to be somehow known by the industry people to go for inspection and to evaluate the buildings on what the criteria, either the building is in a good condition or not, right? So for then that's the thing that need to be implement now. So to kick off with my presentation, so basically the figures here I'm showing that the difference between the reinforced concrete and composite structures, because as I said earlier in my previous presentation, I'm now working with industry to perform wall panel for in the market for Malaysia, right? So basically, we are now focusing to have an alternative construction materials that can be used to be an not so-called replace the masonry unit, but as an alternative to masonry unit. Okay, we try to produce wall panels from inclusion of POFA as seam replacement, and at the same time is cost effective and so high in performance. All right, so in this testing, although non-destructive test, we have various instrument on the non-destructive test. We have GPR, we have half cell analysis. Only for this presentation today, I will focus on two NDT approach, which is rebound hammer and ultra pulse UPV, or ultrasonic pulse velocity, or some country call it as a pandit, right? So basically, these are two basic things in the inspection for concrete structures, a part of other kind of NDT testing, for example, GPR, right, and half cell analysis. But these are the things that is very common and is easy to be implemented in the site. So that's why these are part of the findings, because these are one of the results from the be taken from my master student. Okay. So we are now trying to correlate the data from UPV and also rebound hammer to create a new formulation to to at least in the future, this equation can be used for the construction industry as reference when they are dealing with concrete structures by using UPV and also rebound hammer. Right. So on the POFA itself, I think I somehow have introduced on the POFA. So again, on this research, I'm using the same kind of POFA, which is from the base of the system generated is by using a biomass, okay, from the shell, POFA shell, palm oil shell. So it rich in calcium. So basically, the idea of high calcium element in the cement is to pursue very high early strength. Okay, very high. So that's why, as you can see in my previous presentation, I achieved almost 40 MPa at day 3. Okay, compared to control, which is around 20 to 25, almost 1 times higher. So these are the thing that I think the potential of POFA itself can trigger on the early strength effect with the addition of calcium. All right. So again, for this one, my sample, we have standard flexural beams, which is the size of the beam is 100 times 100 and 500. Okay, it's a RC beam. Okay, and then we go for UPV, rebound hammer, and also 3-point bending test to see on the load and also crack potential for this. So basically, why I'm using 3-point bending test to conclude on the NDT test, because I want to see the potential of the POFA as fiber-oriented materials. Because one of the findings, which I'm not presented here, okay, we took SEM images when we saw that there is a very unique form of binding formation created by POFA as we compare to conventional concrete, which is from cement. And this kind of formation is only it's only happened in the POFA mix, and we believe these are the thing that put an additional effect in terms of ductility and to prevent cracks in the concrete beam. So this is just a preliminary testing. Okay, so there is more data to go, and inshallah I will try to present in another session. Okay, so these are the results from the rebound hammer and also your UPV. So as you can see that there is a great relation between UPV and also a compression test by using UPV and also the concrete cube that I presented before. But from here, that what we can see that the unique of this UPV is rebound hammer is that we can get the results immediately as compared to cube testing. Okay, so it's non-destructive. Your sample is not affected by cracks and so on. So basically, these are the things that trigger me to implement the NDT testing. So on the right side is the result for UPV. Okay, as we can see that there are a reduction in terms of the quality of the concrete itself, in terms of pulse velocity, which is meter per second, when the percentage of the POFA increase, right? So basically, what can I conclude from here is again the potential of the POFA itself to become the first thing, especially in day 1, is act as a filler. So from this good filling effect produced by POFA in the cement makes the concrete denser. Okay, And from this, we confirm that the early strength is come from the good feeling effect from the POFA. Next, promoting the strength due to the action of the calcium. Okay. Also, by transforming the remaining calcium hydroxide that is not fully transformed into calcium silica hydrate or binder products. So this calcium, additional calcium from POFA will create an additional action to perform the calcium hydroxide, the abundance calcium hydroxide into calcium silica hydrate, or what we call as hydration products. And the last one for the continuous strength effect is on the pozzolanic reaction. Okay. So this another graph showing on the effect of the sample, the load versus crack. So these are the unique thing of POFA. I think some of my results here slightly supporting Dr. Johnson presentation before, because Dr. Johnson showing that the potential of the canal itself as a lightweight material from palm oil to somehow creates an early warning to the concrete. Also, we can see many cracks there, hairline cracks, but the sample of the concrete is not affected. There is no total deform produced by that particular concrete with the addition of canal. So basically, the quite a similar findings that also been that I will share now is, as we can see, this blue line represent the loads, and this orange or orange line represent the crack. When we can see that the increase of percentage of POFA reduce the crack that in the sample of the concrete, means that the inclusion of POFA in the concrete sample creates what we call as additional binding effect. And this perform on the elastic and also ductility element, which can somehow prolong the defect in the concrete itself. Okay, so means that we can have a warning or alarm us if anything happen, the concrete will not fail immediately. So so the sign from the hair crackings from this particular element from POFA helps us to ready or to at least to have some identification or warning so that we can prepare to somehow repair or strengthening the structures, right? So as a conclusion, again, we find out that from my first presentation, the action of POFA is by three action: filler, promoting the hydration by transforming the additional calcium hydroxide, and then pozzolanic reaction to continuous the strength or the performance spec, and the potential of POFA as a natural admixture now, and also the potential of POFA as fiber-oriented elements. This is presented by on the load versus crack effect, which what we can see that the higher the percentage of POFA, the load on the failure to the sample is higher, but the crack width is very small. So I think that is a very interesting thing to be shared with others, and some of the testing also already now been done in our lab in Shah, right? And then with that, I conclude my presentation. Thank you for the time. Thank you for the hearing. Right.